Copy 724, right. Center maintain 2000.
Center maintain 2074.
Comment 504 to center maintain 3000.
3000, comment 504.
In this video, we're going to be continue working on this nature of the atmosphere. So the first question we wanna. So this is going to be the second video of 3 video part. We are actually trying to divide the nature of the atmosphere into 3 parts. So this video is going to be the second one of that. So the first thing we wanted to cover today is the dew point. Basically, how do you define dew point? It is the temperature to which a sample of air must be cooled to attain the state of saturation. In layman terms, you can think of it as that this is basically the temperature at which if we attain that temperature right now, it's gonna start raining. But again, it is the temperature at which the sample of air must be cooled to attain the state of saturation. Second one is like when the temperature and the dew points, they are very close to each other, like within 5 degrees Celsius, right? So the temp and the dew point, like let's say if they are 5 degrees Celsius apart, right? What type of weather is likely you would encounter? It's gonna likely happen, and like what would you encounter? So basically there will be visible moisture in the form of clouds, dew, or fog. And you can also expect that the carburetor icing can happen, and we will cover that later on, like what that is. Okay, so what is like the primary factor which determines the type and the vertical extent of the clouds? And the answer is the stability of the atmosphere. So what is like explain the difference between the stable atmosphere and an unstable atmosphere. So the stability of an atmosphere basically depends on the ability to resist vertical motion, right? So like a stable atmosphere makes the vertical motion of the air very difficult, and it actually dampens down the disturbances. Whereas in the unstable atmosphere, there will be small vertical air movements which becomes very big, and it results into a turbulent airflow. So we did cover the difference between the stable and unstable atmosphere. Okay, now I wanted to share a table here. Basically, we wanna list the effects of stable and unstable air on clouds, turbulence, and precipitation, and visibility. So let's just say that this is gonna be number 5. So if you have clouds, right, most of it is self-explanatory, and like if once you understand what a stable air and an unstable air is, you can actually guess. There is only one thing which is actually not that intuitive: precipitation, and then the visibility. Okay, and if we have stable air and if we have an unstable air. So in this table, right, when we have a stable air, the clouds are gonna be the smaller ones, right? It's called the less horrifying one, stratiform. And whereas if the air is unstable, the clouds are gonna be cumuliform. Cumuliform. What's gonna happen in the turbulence? In the stable air, the turbulence is gonna be smooth. And in an unstable air, the turbulence is gonna be rough. What would happen to the precipitation? In the stable air, and the precipitation is gonna be steady, whereas in the unstable, the precipitation is gonna be showery. The thing which is not that intuitive is that in an unstable air, the visibility becomes good, whereas in the stable air, the visibility is fair or sometimes poor. That's the only unintuitive thing you need to remember that could happen in the stable air. So they may ask you, this would be our sixth, right? Okay. They may ask you, like, let's say at the ground, at the surface, we have like significant precipitation. So what would you expect the clouds are gonna be? So if at the ground we have precipitation, so let's say if we have precipitation at the ground, so if there is significant precipitation at the ground, usually it makes that the clouds to be at least 4,000 feet thick. So remember that. So around 4,000 feet thick. Okay. So the heavier the precipitation, the thicker the clouds are likely to be. So usually heavy precipitation at the ground means 4,000 feet, but if it is more, it means that the thickness of the cloud is gonna be even more. So they may ask you, like, during the pre-flight planning, what type of meteorological information should you be aware of, like with respect to the icing? Meteorological information. Okay, the one thing regarding the icing you need to know is the location of fronts. So a front's location, also its type, whether it's warm front, cold front, all those things, its speed and direction of movement. You need to be aware of that. Second is the cloud layer. Okay, this one is the location of the cloud, like both the base of it and the top of the cloud. Basically, by knowing that, you can actually either climb it or you can descend in order to avoid that. Freezing levels or freezing levels. So this is very important in order to determine like how you can avoid the icing and how to exit the icing conditions. The fourth is the air temperature and pressure. You should also be aware of that. This is important when determining how to avoid icing. And basically, icing tends to be found in the low pressure areas and at temperatures at or like around freezing. So that's where the icing really happens. Okay. So what is the definition of the freezing level, right? And how can you determine where that level is? So we want to cover this freezing level. Freezing level is the lowest altitude in the atmosphere over a given location, at which the air temperature reaches 0 degrees Celsius. And it is also possible to have multiple freezing layers, and this happens because of the temperature inversion, and we will deal with that. So again, the freezing level is the lowest altitude in which the atmosphere, like at a given location, uh, like in the atmosphere, it is in the atmosphere at a given location at which the air temperature reaches 0 degrees Celsius. That would be the freezing level. Okay, what conditions are necessary for the structural icing to occur? Okay, so if you have the visible moisture, and we will be talking about the types of icing and all those things, like what are different structural icing are, but what conditions are necessary. So remember that the conditions in order to have this structural icing is that visible moisture and below freezing temperatures. At a point moisture strikes the aircraft. So yeah, then like you can expect to have the structural icing. Okay, what are the main types of icing in an aircraft that may encounter in flight? So as we said, there is types of icing, right? One is the structural, one is induction system, and the instrument icing. Okay, what is this structural icing, right? So that would be our 11th question. Name the type of, like, what are the like there are three actually famous ones. What are the three types of structural icing? Okay, the first one is called the clear ice. Okay, so it forms after initial impact when the remaining liquid portion of the drop flows out of the aircraft surface, right, and gradually freezing at a slow sheet of solid ice, just like in a car when you are uh, like uh, like in the driving in the freezing conditions, and the moisture is hitting the windscreen, and then it freezes and it creates a smooth layer and gradually freezing, right? That is called the clear ice. Second one is called the rime ice. It forms when the drops are small, such as those in the stratified cloud, like the small drizzling is happening, drops are small, the liquid portion remaining after initial impact freezes rapidly. So this is the difference here. Over there was the droplets were gradually freezing. Over here the droplets are freezes rapidly before the drop has time to spread out, right? So what is the difference? The clear is going to be gradually freezing, and also uh, um, like it's going to be make a sheet of solid ice, right? Rime is the drops doesn't even get got enough time in order to spread out, and just rapidly froze. And the third one is called the mixed ice. forms when the drops vary in size and when the liquid drops are intermingled with snow and ice particles. Like if there is different, basically the combination of clear ice, rime ice, even the bigger, there is like combination of like the snow and the bigger ice particles. So everything combined is called the mixed ice. Okay, so what is the action which is recommended if you encounter this icing condition? Recommended way to not avoid to deal with it, right? So basically you need to change your course of action. Like first course of action would be you lead the area of the visible moisture, and basically that would be the answer. Like you need to leave the area. How can you leave the area is like either descending to an altitude below the cloud bases, or again climbing to an altitude above the cloud tops, or turning to a different course. So these you can do these three things in order to avoid basically deal with the icing conditions. These were the questions we wanted to cover. Thanks for watching.